All right, welcome everybody. This is our weekly OPI lifecycle provisioning technical working group. I posted the agenda before the meeting. So today we are continuing our discussion on initial boot sequencing. Want to share with you for a couple of minutes the latest updates that we have on the website, and then we'll deep dive according to agenda. Oscar from NVIDIA joined us today, so he'll be talking about NVIDIA viewpoint on which method they're preferring to use. But let's start simply with just a little recap of what we have so far and the changes that we've done since our last meeting last week. So let me share, we are talking about, again, the coordination markdown page. This is our main page with all three approaches. I'm showing this view, which is just comparing changes to make sure to update you what happened. So we added a few sections here, the working summary of different option 1, 2, and 3, and some comments from ARM regarding the working assumptions that we have. We added few pros and cons on each and every option, option number 1, 2, and 3. We added the flow diagram. I'll show you in a second. We can go through that. Just a few smaller changes here. I personally moved the RESA proposal for boot select to the optional kind of stage. I received a lot of feedback that this is the most controversial ones. Just not to confuse everybody else, so I moved it to an optional section here. There is a good proposal from ARM regarding the DOE improvement. How can we avoid PCI Express SIG standardization by defining our new DOE object? I think it's a good mitigation if we can follow that we can do our own standard instead of going into and waiting for PCI Express SIG to actually adopt the changes for the option number 1. We can discuss it as well. We added few assumptions into option number 2 with the driver edge check. I'm going very fast through this because I assume you all can read, so you can click on the links and read everything in much detail, so that's fine. So we added a few assumptions here. One of the most important feedbacks in this part was regarding ARM. So today we see a lot of NIC vendors not giving option ROM for ARM, just for x86. So we put it as an assumption. So if we go in with this option, we have to support both x86 and ARM. So it have to be ARM option ROM in addition to x86. Another improvement to option number 2 is what we, and as example, the network media state. So there is an actual mechanism in UEFI that you can actually poll the state after the enumeration until the driver and media is ready. So this is an optional improvement for the option number 2. It doesn't solve all the problems like initial enumeration, but it's an improvement on option number 2. Again, we added few pros and cons here in this option as well. For out of band, I added myself a few pros and cons here. We expanded PLDM to I2C, I3C, PCIe, VDM, and others. We also have a few comments, discussion on SPDM here. Just a few typos. And mostly, and USB is a new addition here as well. This is the diagrams that we added. This diagram from RESA on option number 1. What happens during the power on if we have the dedicated PF0 with different status registers, max boot select, OS boot select, and how the flow looks like. So I think diagrams helps us a little bit. We also created a new folder, vendors. In the vendors, we put here Intel and Marvell so far. It's their view of how things should work. And Marvell just did a survey response for RESA questions. So Oscar, if you're here on the call, if you can also submit the survey responses from NVIDIA side here, it will help us a lot.
Okay, I will do that.
Perfect. So this was extremely quick overview, but the reason I did it quickly again, because you can all deep dive on this. And this is the final version of how our page looks like. So basically, we have 3 approaches that we currently explore. Any questions before we jump into Oscar? While you're thinking about questions, I want to welcome Samer from ARM. It was extremely helpful, a lot of good comments that we have from ARM perspective. So welcome to the weekly calls.
Thanks, Boris. Looking forward to contribute here. I see some familiar names and faces, so it's a small industry. So looking forward to working with everyone.
Hey, Samir, how are you doing?
Very good. Hi, Oscar.
Excellent. So no questions. Everything is clear. Everybody's reading the page frequently. It's very fast updating page. I really like it, the pace we go in. And hopefully after we finish the round, we can make a choice which option we are going with.
Yeah, hi Boris, it's Andrei here.
Hey, Andrei.
Sorry, I missed a few calls, but it was a sequence of events I couldn't avoid. So, but I'm back now. Yeah, I'm reading this page again, just very quickly before our start of this meeting. I went through it. Again, talking about misspelling. I think in a few places it says MTCP. I believe it should be MCTP.
Yeah, if you see me spelling, we're all humans, you can fix it.
Yeah, no, because I was like confused because MTCP means something completely different. So like in SPDM, when we start the SPDM section, it says SPDM runs over MTCP. I think it's MCTP.
Yeah.
Yeah.
I'm a bit dyslexic, so it could be from me, but yeah, feel free to fix it. Yeah. We post all our recordings now on YouTube. So if you want to catch up, not just the text of the page, but also the discussion itself, you can all check our YouTube channel and, speed it, and you can listen through the recording as well. If you want to, Andrei. So, any questions, Andrei, or others on what we see on the page before we jump into Oscar? Okay, I guess not. I do encourage you to read through the latest updates. I think that DOE improvement from ARM and also the media ready polling mode improvement for the option number 2 for Intel concerns, and USB additions for the out-of-band management. I think all of those are important to consider. So read them through, click on the links, make sure you're aware this is happening. So Oscar, your floor, go ahead.
Okay, so I'm gonna be brief. We had an internal conversation about this topic, and we all agree internally that we should go with option number 3. The reason is that since our DPUs have a BMC for management, it would be much better for us to take advantage of the management during the power on sequence. And that's pretty much it. So as NVIDIA, we want to push for the option number 3.
So let's try to expand on this a little bit. So I'm just going to share. So option number 3 is talking about out of band with platform or server BMC assist, right?
Correct.
So in this option, we present several possible protocols. So can you expand a little bit? Are you seeing yourself using PLDM and CSI OEM, Redfish, PLDM RDE, SPDM, or USB? What kind of protocols and physical transport you see?
So physical transport, we know the PCI Express 6 is going to include a USB 3. And we want to take advantage of that for our management. But today we have on the current slots, we probably only can use the SMBus. So probably PLDM over SMBus. will be our option for now.
So PLDM over MCTP
Over
over
SMS.
SMS.
Hey, can I ask a question here, Boris, Oscar? And
Absolutely. Feel
there,
free.
I'm a bit confused about some of the language in option number 3. So PLDM can be on any of these physical transports, right?
Right.
It's really PLDM plus MCTP and optionally SPDM as well. So you can do secure MCTP transport. So when we say USB to PCIe, it's really just a physical transport for MCTP PLDM. Is that the intention?
That's the intention. I mean, on the PCI Express 6, they want to include that for management. I mean, to replace, or actually not to replace, but to coexist with the SIM bus, because the SIM bus is too slow.
Yeah,
So-
so I think the answer is yes, Samir, the PLDM over MCTP over USB. This is the answer.
But it doesn't have to be over USB. It can be over any of these protocols, depending on the system design.
Mhm.
I would also interject with like SM bus. You typically have a lot of muxes between the platform BMC and the device. So you end up not being able to do asynchronous notifications. So like basically all of the communication has to be initiated by the platform BMC. So you do a lot of polling unless you also have an interrupt line that goes back for each device, which a lot of times that isn't there. So not only is I2C SM bus slower, but you are limited in basically the direction of communication as well.
Right. Yeah, because the MCTP requires multi-master. So, and when you have switching between that's problematic. You have to actually own the switches all the way to the target to be able to establish that communication. Yeah.
And Oscar, if you don't mind, let's go just a little bit more into explanation. The reasoning behind option number 3 is preferable. If we can communicate just for the group, so we have a little bit of background, why you think it's more preferable. Let's talk about, timing, PCI Express.
It is basically timing during the power on. So usually we have our DPU card that has its own BMC. Correct. So the BMC here and then on the board will actually manage the power on of the DPU processor. So we want to actually have a flow where that includes the BMC. That's pretty much it.
But correct
So
me if
that
I'm
would be
wrong.
more like option 4, I think, right? Not option 3. Option 3 is about the platform BMC, meaning
Right, but
BMC on the server.
but you see there is a XPU or DPU management. That's our BMC.
Okay, yeah. So
But
that
let's
was
deep dive.
intentionally-
Yeah,
that was
Lee,
intentionally
yeah.
kind of-
Let's deep dive in this exactly. Mhm.
It could be whatever, right?
Yeah. Exactly.
But so but that would mean that your BMC would have a northbound PLDM interface, right? It would be participating so it would present an MTCP interface to the server BMC
To the platform BMC.
Okay. So you're not expecting the platform BMC to talk Redfish to your BMC. You're actually going to you're going to let the server BMC be a master and use standard DMTF protocols to talk to your BMC.
Correct.
Okay.
Today can be done. Sorry, today can be done via SIM-bus, but when we got the PCI Express 6, we want to use a USB 3.
But to eliminate confusion, Oscar and Lee, correct me if I'm wrong, but today in the NVIDIA cards that we're using, there is actually not a BMC that is responsible for termination of PLDM or NCSI. The firmware of the NIC and the independent management controller, which is not BMC, is what's responsible for doing that, because until today, still NVIDIA had. Maybe this is changing. I'm not commenting on that. But until today, there were two SKUs of with BMC and without BMC. So until today, there was additional management controller on the NVIDIA DPUs, which was responsible for terminating TPLDM and NCSI. And what you say, Oscar, is this is going to change.
So future products will include that connectivity for the PLDM. Okay, so you're probably talking about BlueField 2 and 1.
Yes.
Yeah. So the next generation will have the PLDM enabled.
So PLDM and NCSI, if NCSI, but probably
The
PLDM.
NCSI connects to the DPU arm. The connectivity to the management or the BMC is PLDM.
Okay.
How is this different from any network card or PCIe card that presents MCTP and PLDM and does not have a BMC on the card? What I'm trying to get to is there is really no dependency on you must have a BMC on the card to play into this option, right?
Correct. Yeah. So that's the reason we prefer this option, because it can coexist with other implementations that don't have the management, or it's a different type of management. Instead of BMC, it could be the DPU itself that is doing some management.
This is why we kept this option, Samir. This is why we kept this option to be XPU management. We specifically didn't say whether XPU management is APU or DPU BMC, or it's a kind of discrete management controller like in NICs, which doesn't have the BMC. So this option focuses on server or platform BMC, but the DPU management is not specified. It can be either option, I think.
Yeah. You just have to be careful about the connectivity, right? Because obviously, once it leaves the gold fingers on the card, right, how things route can go a bunch of different ways, and it's all dependent on the vendor's implementation.
So the cons of this option, just to make sure, just to trigger the discussion, the cons of the option, as some people discussed on this call, is more complication. There are a lot of things that need to change in order to accommodate for this option on both server side and the DPU side as well. And this is out of band. The pros obviously is we don't deal with PCI Express, the timeouts, the physical functions, PCI Express SIG, all of that stuff is kind of avoiding all of that.
So this is more of server BMC centric approach, right? We are setting up the wait for the XPU to boot on the server BMC or the server BIOS, and then it will just hold the PCIe enumeration, and until the XPU is ready, then it starts booting up.
Yes, as you see at this diagram, basically the server BIOS is going to wait until the card is ready, and there should be some kind of notification like we show here that DPU is ready. Once DPU is ready, we can continue the enumeration process. Once enumeration is done, we can continue to option ROM and the booting as usual.
Just for comparison, can we discuss the option 1 as well, which talks about the in-band management case? Because there, I think it's more XPU-centric approach, right? Because the end user will coordinate the boot order via the XPU UEFI, right?
Not really. The option number 1 is the same view that server is in control. The only difference is that the communication and the wait time is completely between the server CPU and the DPU without any involvement of BMC. So what
Yeah.
happens here, once the power on is established, we have immediately within 1 or 3 seconds, physical function 0 presented with new capabilities of OS status, max boot time, and optionally boot select.
So
Then
where does this step 0 or step 1 set XP OS boot path? What exactly that does in this case?
yeah, so what happens is we wait in this state until DPU reports us that operating status, OS status is booted, or we have a timeout. So at this stage, we are communicating over PCI Express with this new physical function 0 over PCI Express to read this register, poll this register again and again until the DPU reports that, okay, I'm booted. And then the UEFI or BIOS can continue for enumeration. Okay, enumerate and then continue the regular UEFI operation with option on and everything. So this option eliminates the need for the external BMC to be involved because the communication is between the server UEFI and the DPU over PCI Express only.
And I think before we dive too deep into this option, I just wanted to make a comment that I made earlier on Slack as well. Option 1 and option 3 are not mutually exclusive, really. Right? You could have detection mechanisms, whether in the BMC or in the server BIOS, to detect if the DPU supports this option or that option, and combine both in the implementation of the same platform.
I try to capture this, Samir, in this working summary, that they doesn't necessarily need to pick one option.
Thanks.
I'm not saying this is what we voted for, but just wanted to capture it. Alok, is it clear? Yeah, any question?
So
Yeah, I need to take a much closer look on the page, but yeah, these are some of the questions that just came up during this discussion. But yeah, thanks for the clarification.
I have a question about option number 3.
Yes, Daniel.
It's in general, it's clarification. I think during the last meeting, it's been mentioned what there is a very small number of use cases where server may not have BMC.
Yep.
And so if this is the case, then the XPU board will not be powered on such a systems, right? It will not be used. People cannot use the, if it's a discrete board like a PCI board and they install it in the server without BMC, it means this board won't work, right? Is that correct assumption?
So good question. And I think it goes to Samir's point previously that if we have a use case when we don't have a server BMC present, obviously option number 3 is not going to work. So maybe in this case, what Samir is suggesting, in this case, we choose option number 1 as alternative option for those systems where BMC is not present on the server itself.
And not only on those systems when a BMC is not there, but even on systems that has BMC, technically there is no reason that 1 and 3 can't be combined in an implementation that wants to cover more DPUs.
Yep. Just the burden of implementing both of the options on both server side and BMC side, DPU side. Yep. But I don't see a technical reason not to do both of them. Okay, more comments? Alok, Lee, others?
So I was looking at option 1 for the set OS boot select.
That's a controversial one. This is why I pushed it into the optional. Riza, I hope you're fine with it.
Yeah, that's fine. There are some use cases, excuse me, there are some use cases where we need to go into a maintenance mode and maybe boot from something else. And so that's why that's there, but certainly we can continue to discuss that.
Yeah, it just seems like the arrow needs to be drawn in the other direction, right? Like you need to either the server's requesting it. I mean, having the XPU set its own boot select, I mean, that doesn't even mean anything. Right? I mean, are you just reporting it or
Well,
you
in this case, it's meant that the user is setting the boot on the XPU, and it may be in band or it may be out of band, and that wasn't, maybe that's not clear.
okay, so it's that first line up there where you're trying to
Yeah.
set.
And that's exactly what I was referring to when I said like comparing the two option 1 and option 3. So the very first triggering point will be the user will set the boot order, right?
Yeah,
And that will be a direct interaction with the XPU by the end user.
But it also requires that the XPU be in like a good state before you get there. Like there's no like crash recovery, like
Mm.
how much stuff has to be running on the XPU for the user to be able to talk directly to it to set this boot status, right? There's no, it's not like if the XPU doesn't boot, right, then you can use this to recover. You can't, because it has to be essentially running and are in a good state.
well, yes, it has to, well, it doesn't necessarily have to be in a good state. We hope it's in a good state to change the boot path or the boot order. But if this is a PCI register, that should be able to accept that. Now, if the software in the background on the ARM is not functional enough to read that, then that's a different story, right?
What I suggest is, because again, I think it's not a core of our discussion. The core of our discussion should be on the boot sequencing itself and the wait and hold, at least initially. This is why I just suggest the boot order. Let's shelve it for a second. Let's try to ignore this first arrow of setting the boot pass. And then let's focus on what happens on the power on. During the first 3 seconds, DPU will present the OS status, whether it's booting or halted or, you know, booted or completed, whatever, maybe a max boot time. And then we do this polling wait on OS status to finish into booted. And once that is done, we can continue with enumeration. And after we kind of accept this phase and approach, we can then go back and discuss the boot ordering thing. But I just feel that we need to focus on the core functionality, which everybody needs currently, is the synchronization between the CPU in the server and the DPU.
Yeah, I agree. That's a prudent thing to do.
Also, another minor comment, the naming or the terminology for the actors. So here we are calling XPU CPU on the extreme right. I mean, if I take an example of Intel IPUs, they have 2 subsystems, IMC and ACC. So to me, it's a bit confusing. I think here we are referring to, in general, the XPU booting status. That includes both the subsystems, at least for the...
Yes, but because it's PCI Express, probably this is not going to the IMC, because IMC for me, it's management controller. So I think it's correct to assume that this is CPU, because we are talking in-band over PCI Express. No?
I don't think so, no. It should be the IMC, but somebody can from Intel.
Yeah, actually, Alok, I don't think it's relevant here. It will be hidden, and let's say if IMC replying to all the stuff, then IMC can either ignore ACC if needed. Let's say we will boot ACC, or we don't even have an image for ACC when we boot it first time. So then IMC can manage it. And then IMC again if we also boot in ACC, then internally IMC will monitor and detect ACC boot, and then will report it. So for me, it's hidden. So yes, CPU in this
Calling
case, it's
the
is
only
an
concern on
overall
the
system or IMC only.
CPU, to me, it sounds like very much ACC specific. So that what I.
Yeah, but I think it's a too low level detail here, so we can, especially for this case, we can look at IPU, if you're talking about Intel IPU, as a one black box which has CPU complex, and okay, it's divided between IMC and ACC, but again,
Let's
maybe-
remind ourselves why we needed this option and boot synchronization. The reason we needed it is to wait until UEFI before the enumeration, because we don't want to support hot plug device, or we wanted to give a DPU IPU a chance to provision all the physical and virtual functions. So the enumeration that happens in BIOS can discover those. This is a main reason that this option exists, is we want something before the enumeration.
So the PF and VF both should be in the ready state before the enumeration or the UEFI continues, right? At that
Yes.
stage.
Yes. For example, if you do an emulated storage device, right? So let's say Intel, for example, if we're talking with Andre here from Intel. So if we have SPDK running on the ACC, presenting NVMe emulated devices, connecting to some kind of storage, doing all of that stuff, and we want to boot from that storage, we have to wait until the ACC operating system is fully booted, SPDK application is fully running, before we can do the enumeration in UEFI if we want to boot from that emulated NVMe devices. So I do think maybe it's too low level details for now, but I do think that for us, it will be extremely useful also to consider that OS boot is actually ACC boot state and not IMC boot state.
Yeah. So maybe rather than going into low level details, I agree. I mean, that may be too detailed. Can we call it like just an XPU here and consider it as a full blown device, as a black box, and that should be in a ready state before this enumeration starts.
You mean this piece on the diagram instead of XPU, CPU, just an XPU?
Yeah.
Yeah, if Reza is okay with that, I don't see a problem.
Okay, thank you.
But you understand the reasoning, right? What's important, right? We need to wait here before the enumeration, which is why we do feel that option number 2 presented by Intel is not going to work, because we cannot really wait in option ROM, because option ROM is after the enumeration happens. So we cannot really use option number 2 presented by Intel if we want to wait before the enumeration.
I'm not sure if that is the case. I mean, if the optional ROM is supported by the XPU, then I mean, I agree. We will require the drivers to be supported for the option 2, which is the optional ROM scenario. But
the wait state is in a completely different stage. Look at this picture, right? The polling that we want to do is before the enumeration. The option ROM is where UEFI continuous happens. We can add here a specific box for option ROM, but it is after the enumeration is finished.
And option ROMs run at the end of post.
Exactly.
And it's a major lift to move option ROMs from the end of post to the enumeration section.
okay.
So, Reza, just to emphasize this, maybe just an option we can add where UEFI continues. We can add another box here, option ROM, just to emphasize that this happens after the enumeration is done. What do you think?
I could do that.
So if I understood your comment, Reza, so optional ROM comes into play after the host is fully set it up and booted up?
Correct.
If you look at the traditional UEFI diagrams that are out there, there's a lot of literature out there that show the UEFI boot phases, right? You have PI, Dixie, and then at the end of Dixie, you have a phase called BDS, boot device selection, and then you have the OS bootloader path. The option ROMs is nothing but a UEFI driver, just like many of the UEFI drivers and other types of drivers like Dixie drivers that exist in the BIOS itself. The option ROM is a UEFI, they call it a UEFI driver model driver. Those drivers get loaded from their source initially during the dispatch of drivers, but they are not started yet. So they don't do actual hardware management. They are just sitting in memory. And the hardware management does not start until very late in post in the phase called the BDS. Based on some policies programmed in the UEFI, UEFI may want to start everything, or it may decide to skip some option ROMs and some drivers and do a quick boot to only a specific NVMe drive, for example. That's possible in UEFI. So like Reza said, not only it is difficult to move this earlier, it is just fundamentally against the flexibility of UEFI of allowing it to decide using a policy what to start, what to boot to, and what option ROMs can be ignored.
So Miro, can I ask you to fetch one of those diagrams you're talking about, and maybe we can submit it here in the driver ready check section just to show the process and the complexity?
Sure, yeah, I can give a pointer to one of those diagrams.
Yeah, thank you. Okay, so I do want to ask this group of people. We heard some vendors really want to go with option number 3, which is out of band, both on the server side and DPU side. Or we hear the need to have kind of option number 1. So I do want to kind of brainstorm with this group, like, can we at this stage already say that option 2 is probably not good enough, or maybe we'll give it some more time, but eventually we say that. But between option number 1 and 3, I'm kind of reluctant to say that OPI is declaring both equal or whatever, because maybe it's too much work on both server side and DPU side to support both of those. But just want to hear opinion of different people. Like, what do you think between option 1 and option 3? And maybe if we have some time, I do want to discuss at least this DOE improvement that helps us eliminate the PCI Express PCI SIG specification and allow us to do messaging instead of fixed registers and do our own specification as well. So just feel free to unmute yourself and comment what you think.
Yeah, Boris. I think we'll have to do option 3 as a short term. As a stopgap, sort of an intermediate stepping stone before we do the in-band method. But also,
so if we put it out there at all, it's going to be very hard to pull it back. That's the only consideration. I mean, we may have to embrace both of those long term, but again, it's a good discussion. But if you put it out there, nothing's temporary.
Yeah, I understand that. Yeah.
I also think that there is maybe option number 1 can be already today implemented with a lot of DPU vendors even today, because we see that many of the companies have some kind of version of DPU which is FPGA based. So there is no problem implementing that. And some DPU vendors have software defined or upgradable PCI Express implementation. So we can also do in-band option, even, you know, relatively quickly. If Oscar, you're still on the call, I do remember that NVIDIA has a firmware-based PCI Express implementation. So let's say if we are to go with option number 1, is it possible for NVIDIA to actually implement that without new ASIC respin, or it's impossible?
I cannot comment on that right now. I can bring that answer next time. My understanding is that we want the option 3 because of the new products we have, where we are relying on the management of the DPU.
Okay.
When looking at option 1 or evaluating it in your teams, I would strongly suggest looking at the DOE option, because that then eliminates the topic of, oh, we'll have to wait for a next PCIe spec release to define these registers. With DOE, any spec can define a GUID and then define what goes into that mailbox. The PCIe spec just defines a generic way of using the extended capability registers to discover that the device has a DOE hardware ability to do a mailbox. And then you iterate through those mailboxes that are identified by their GUIDs to pick a specific object or specific feature that object describes. And then the actual content of the data for that particular object or feature does not have to be described in the PCIe spec at all. It can be described, for example, the CXL spec has its own DOE that uses this feature. The PCIe spec itself defined the DOE for SPDM and for component measurement authentication. My question here, and maybe this is more for the XPU hardware teams to look at this, is if an XPU has already some DOE hardware to do any of these features, for example, let's say CMA, my belief is that it can be extended with just firmware change, even if the PCIe implementation is in the hardware, it's in the ASIC. I can't confirm that, so that's implementations will have to look at that. But nevertheless, this approach is completely avoids going to the PCIe seg and requesting a spec change.
That's a good addition, Severin. Thanks.
Yeah, it would be interesting to know how many DPUs currently have DOE capability.
And I guess it helps that a lot of vendors now seeking SPDM and secure communication. So if that is available, then adding another DOE object is probably not a big lift.
And the other advantage of it is because now it becomes like a mailbox with a table of fields. We can add to it, we can define fields. So this debate on whether we need the OS boot select or not, or whether these enums are sufficient or not, this doesn't have to be settled on version 1 of this. This can grow over time. And you can make it as complicated as you want or as simple as you want. CXL, for example, made it so generic that it has commands of the form of send an event and get an event, or set a feature or get a feature, and all events and features are identified by IDs. So it's almost a whole programming interface, very much like NVMe MI, just a more using a more generic hardware feature, which is the PCIe DOE.
Another comment I wanted to make sure people understand, jump into option number 3 now, with out of band. So you see this line between server BIOS and server BMC. So several people asked me, and I just want to make sure that we're on the same page. There are no standards today acceptable, right? To define well communication between the BIOS of the server and BMC of the server. So we do expect that this is out of scope of OPI to define. Server vendors can do what they want. If spec emerges, I think Samir, you said something about that there is some proposals, but if spec emerges, this is on the server vendors to figure out what they're doing in this space. But what we actually do want in option number 3 is we want the communication to be standardized between the server BMC and the DPU. And one of the options, as we discussed earlier on this call, is, for example, standardizing on PLDM and defining all the proper registers, whatever it's available for us to actually do the boot synchronization, boot status, and everything like that. But just to make sure people are aware that server BIOS to server BMC is something that I personally feel we don't need to go into and specify what it is. It can be OEM proprietary thing, or it can be standards. It's for server vendors to figure it out. Make sense? Ariza, what do you think from the server, from HP perspective?
Yes, absolutely. I think we all have proprietary interfaces in that area, so yeah, we need to keep it that way. If not, it's a heavy lift. I mean, if it becomes standardized, I think we would welcome that. But for now, we need to keep it proprietary.
Yeah, just wanted to emphasize it.
One of the things that probably need to be examined for option 3 is, so yeah, we say MCTP and PLDM, but are there enough constructs to complete the story with PLDM, with the existing PLDM specs? And is that detailed here, or do we feel that some changes to the spec are needed? Keep in mind that some of these things that you're looking at in the PLDM spec may have been in the specs for a long time, sitting on the shelf. I don't know how much was implemented. So when it comes down to real implementation, are these definitions sufficient, or some are now out of date and need to be updated?
So Lee, you proposed option number 3. So if you can comment on that, and Oscar, because you are looking in NVIDIA to implement PLDM, it also will be interesting to know what is proposal from your side on the specific fields and registers. Are they sufficient enough, or do we need to extend the spec somehow to add more things for coordination?
Yeah, I mean, I think I took these definitions from the latest version of the spec reference below. What's missing here is I need to go back and look at PLDM for Nick and then come up with some good sensor names, right? And then that probably cleans up about 90% of it.
With this option number 3, do we need to go into DMTF and say we are going to use PLDM for SmartNICs? DMTF already did a bunch of work with Redfish for SmartNICs, so we want to come and say we want to do this, and this is the field names or naming or additions or whatever we want to do, so they support it and have official kind of update or spec.
Yeah, so that's what PLDM for Nick kind of did. So you can imagine there's a northbound side and a southbound side. So the northbound side is Redfish from the BMC to the user, right? But from the BMC to the device, it's going to be PLDM, or you could do RDE, right? So that's kind of why I threw RDE, and there's another option. So you could take the kind of the SmartNIC Redfish schema and throw RDE on it. But trying to think, I don't know that boot progress is defined anywhere in a system Redfish schema.
It's defined as an implementation defined. So there is some standard, but it's not sufficient. It's actually a place where both sides of the specs, the PLDM and the Redfish, is gapped today. For ARM, for example, we opted to using the UEFI status codes rather than the PLDM boot progress codes, because the UEFI status codes are more relevant, more complete, and extensible with OEM bits, etc. And for Redfish, they initially decided to just keeping it a very small subset of checkpoints. I think they defined like 5 or so enums, but allowing people to do OEM specific values, and that includes the UEFI status codes, just pushing the whole 64-bit. So Lee, this might be an area we might want to look at more carefully, because when I last checked the boot progress part of PLDM, it was not suitable for at least regular server boot.
Right. I mean, so to be honest, kind of the information that I thought was relevant out of this was, okay, we're in the process of booting, right? We're in UEFI, and then after you got past state 21, right, where UEFI is handed over boot to the OS, then you'd go up and look at the OS status, right? So right now there's only a termination status. What you want is to like know that, okay, I'm in single user mode, multi-user mode, and all my services are healthy, right? So could define some more status registers that kind of give a state of like general OS as yellow or green, fully operational, partially operational. I mean, I think there are states like that. So there's some rough edges to kind of rub off here, but
Yeah, I agree. That makes sense.
So
Is,
this was
it's
excellent
not-
discussion. Yeah, go
OS,
ahead.
have like all the services up, and then so that that the boot targets are available.
Thanks, Lee. So this was excellent discussion. We have 4 minutes left. I want to just ask an opinion where we go from here. I feel that we did quite a big of deep dives on all 3 options. We need to kind of start making decisions, or people feel they need more time to digest, to go back to their companies and get more feedback. I want to understand what people other than me thinking, how to progress here, because we don't want to drag this. I think we already beating the dead horse almost. So just be honest, and what do you think the next step should be?
I would like to hear DPU vendors' opinion about the DOE option. About using DOE, their capability for using that.
Oscar, can you take an action item to check internally about DOE option and come back to us?
Yeah, I'll check about the DOE, and I'll reply back.
Andre, can you take an action item from IPU side?
Yeah, actually, I already wrote it down. So yeah.
And who we have here from Marvell? Chetan? Who we have Marvell here? Chetan is not here. Usually here.
Yeah. Yes.
Yeah. He may have dropped out. I'll inform
Rahul.
him.
So Rahul,
Yeah.
you're taking the action item?
Yeah.
Okay. So the action item is for now is deep dive into the DOE option here, described here in this page. Just so people not confused, I'll post it in the chat so people can click on it. and come back whether it's acceptable, not acceptable. If it isn't, we have our answer. And I do want to kind of think, how can we maybe do both, option 1, option 3, or we have to choose one? I hate us to go in 2 directions at once, but maybe we don't have a choice. It was a new comment for me from last week and this entire week that there are servers without BMC. So if that is a real use case, we want to support servers without having BMC, maybe we don't have a choice, but also to adopt option number 1. Okay, so action items, DPU vendors took one. Oscar, another action item from you from previously is to submit into vendors folder response to the survey. And action item on Samir is to help us with a UEFI diagram on the option number 2 to show where enumeration versus where the post and the option ROM are in the sequence, in the boot sequence.
Is someone from AMD Pensando on?
I don't see VPN, but I will ping him. I'll ask Vipin about this question as well. Yeah. Thanks, Reza, for reminding.
Thank you.
Excellent. Thank you. Good discussion, and see you next week to continue this.
Thanks, guys.
Recording will be on YouTube. Thank you.
Thank you.